So let's briefly review the steps to hypothesis testing. So steps, the first thing we need to do is specify our null and alternative hypothesis. Alternative hypothesis. So for example, our null hypothesis, we usually denote H naught or H subscript 0. And one such hypothesis could be something like this. So this is like, our null is that x1 has no effect on y. And our alternative will be what holds if the null is not true. It can be one way or two ways. Let's just do a two-way one here. So beta 1 doesn't equal 0 is alternative. And so we usually say alternative by H subscript A here. So that's the first step in hypothesis testing, to actually specify what we're going to test. The second step is going to be pick a significance level. So we want to set a threshold for how often we're willing to make a type 1 error here. So we often denote that with an alpha for the significance level. So for example, might be 0.1, so 10%, 0.05, 5%, or 0.01, 1%, 10%, 5%, 1%. And so this is how often we're willing to make a type 1 error, how often we're willing to reject the null when it's true. So remember, the alternative, the type 2 errors are, failing to reject the null when it's false. But here we're specifying our threshold, our willingness to make a type 1 error. So the third step is to calculate the test statistic. So we're going to use a lot of the times in this course either a t-stat or an f-stat. There's lots of different kinds of statistics as well, but these are the two most common ones we're going to see in this course. So we're either going to use our regression results to construct a t-statistic or an f-statistic. This is what we're using to test this hypothesis. And the fourth thing that we're going to do is use this test statistic to make a conclusion about our test. I guess we're using our significance level there too. And there's kind of two ways we can think about using this test statistic to make a conclusion about this test. So remember, we're going to reject the null or fail to reject the null. And let's talk about two different ways that we could come to a conclusion about this. One's going to be using critical values, and one's going to be using the p-value. So let's quickly erase this and kind of expand on this fourth step here. All right, so let's expand kind of our discussion of this fourth step, this using the test statistic and our significance level to reject or fail to reject the null. So use test statistic, and I guess we're using the significance level as well because that will be important for our conclusion, to reject or fail to reject the null. Reject the null. All right, so there's kind of, in general, we can think of two different ways of coming to conclusion with our test statistic. One way is going to use critical values. This is probably a way that you're much more familiar with from your previous statistics courses, but we can also use p-values to make a conclusion about the test as well. So let's talk about this first option, let's just call it option A, use critical values. So our test statistic is going to have its own distribution, and the assumptions that we end up making are going to tell us what the shape of this distribution is. So here's the PDF of our test statistic. So this is the PDF of our test statistic. So we're going to assume it has this shape, but depending on which test statistic we use, the shape might be a lot different. So the F distribution looks a lot different than this. This looks more like a normal distribution, right? Or a T distribution. Okay, so here's the distribution of our test statistic, and it's going to be a function of our sample, which is why it's a random variable. And so what we're going to use is, remember, alpha is going to be our significance level. So this is our tolerance for a type 1 error. And so remember, a type 1 error is rejecting the null when it is true. And so we're going to have this distribution of our test statistic. And what the critical value does is it picks, assuming this is a two-way test here, it picks the t-stat, or the test statistic you would need to reject, to actually commit a type 1 error at this rate. So for instance, let's say this is a two-way t-stat. This is the critical value. If it's a two-way, I'm just going to put alpha divided by 2. Just take the absolute value or whatever you want. T crit alpha divided by 2, and we'll put a negative sign out there. And so basically, you know, if our test statistic is outside of further in the tails of this, from these critical values, I should say. So let's say we actually got a test statistic. Let's continue this over so I have more room here. So let's say we actually got, maybe a different color pen will be helpful. So let's say we got a test stat of this. So this was the positive test stat. This was the negative of the actual test statistic that we get. If we're further in the tails in this critical value, so if our test statistic is bigger than this critical value, it's telling us, you know, there's less area in the tails. It's telling us we're going to reject the null because it's, you know, the probability of committing a type 1 error with this test statistic is going to be less than our threshold for making that kind of error. And so let's just write out how you do it. If your test stat is greater than your critical value, and again, it could be alpha divided by 2, whatever your critical value is, you reject the null because it's telling you you're further in the tails, so the probability of committing a type 1 error is less than sigma. Now, on the other hand, if your test statistic is less than your critical value, the critical value of your test statistic, not necessarily the t statistic, you're going to fail to reject the null. All right, so this is how we're going to use critical values to make conclusions about our tests. So this is kind of the theory behind it, and here's the rule over here. So in general, how we're thinking about it is, if our t-stat is bigger than the critical value, the probability of committing a type 1 error is smaller than this sigma, this threshold that we've specified before running this test. Now, if our test statistic is less than this critical value, so somewhere in here, let's say, then the probability of committing a type 1 error is larger than we're willing to make. So that's why we're going to fail to reject the null. So that's the first option for coming to a conclusion about our hypothesis test. Now the second option has to do with p-values and actually calculating the p-value, which is going to be the probability that you actually are making a type 1 error. So the second way of kind of option B in terms of coming to a conclusion about our test, so option B, is going to be using the p-value, or the probability value is another way that it's sometimes, another thing that it's sometimes called. So what the p-value is the largest significance level that you would fail to reject the null. Or put another way, it's the probability, assuming the null is true, that you got a result as adverse to the null as you did, given the null is true. Hopefully that made sense when I said it, but let's talk about it graphically here. So again, we have this distribution of this PDF. So again, the PDF of our test statistic. And so what essentially the p-value, so we're going to end up centering our test statistic. So this is our test statistic, assuming the null is true. So the null would be kind of this middle of this test statistic right here. And it's saying how we're calculating the p-value is we're plotting our test statistic. So this is the negative of our t-stat, or our test statistic. I'm going to call it a t-stat here. This is the positive value of our t-stat. Again, I mean test statistic as opposed to like t-statistic in general. And what the p-value is doing is it's calculating the area in the tails. So what's the probability that we got a result kind of way out here, but the null is true? Well, that's going to be the sum of these two areas in the tails, right? And that's essentially the probability of committing that type 1 error. And so a p-value is actually calculating the largest significance that will fail to reject the null. So that's how a p-value is working. So we're going to, well, how it's calculated, I guess, is we're calculating the area, on a two-way test, to the left and to the right of our test statistic we actually calculated. Now, with f-stats, it'll just be a one-way test, but it's kind of the area in the tails. What's the probability that we got a result way out here, and this is true, and the null is true? And so, in terms of conclusions, if the p-value is less than the alpha, we're going to reject the null. Right? So if the p-value is less than, if the probability or the largest significance level that we fail to reject the null, if that's less than the alpha that we're testing against, the significance that we're testing against, we're going to reject the null. If the p-value is greater than alpha, we're going to fail to reject the null. Now notice that this p-value gives us way more information than just using the critical values to reject or fail to reject the null. It's actually telling us the largest significance level that we'll fail to reject the null at. This is more information. So if we had a p-value of, let's say we had a p-value equals 0.011 or something like that. Well, we'd reject the null at 5%, but fail to reject at 1%. Right, that would be 0.05, 0.01, right? So here, 0.01 is less than 0.011, but 0.011 is kind of less than 0.05. Right, just using this. All right, so notice that it's so close to this 1%. And if we just, gave this as our conclusion, we're really losing some of the information that we've gotten. The fact that this is the largest significance level that would fail to reject the null at, as opposed to just rejecting and failing to reject at 5 and 1%. So there's more information when we calculate this p-value.